Algebra homework number 19. We'll start with graphing some linear inequalities. In this question, you'll be given a linear inequality that is not written in slope-intercept form. If you manipulate this sentence, you'll be able to find the y-intercept and then the slope to graph the inequality. Afterwards, you'll be asked to determine the type of boundary line and the shading area. Let's take a look here at our linear inequality. Okay, now that we've manipulated it by writing it in slope-intercept form, we begin at our y-intercept on the y-axis at +6, and then we follow the directions of the slope, which has a rise of 3 and a run of 4. So now I'm going to use the Delta Math graphing tool. So I'm going to erase what I wrote here with my marker, and I'm going to use the actual graphing tool with my mouse. So 6, and then up 3 from there, and over 4. You'll see a line appear. After you click twice, they'll ask you which type of boundary you want and which type of shading you want. So because I have a less than sign, I need to change my line to dotted. You just click it more than one time to change it between the two types. Now, I am less than, and we read our graph from left to right. So if I was walking on this, graph, then I would be walking this way. So less than would be below my feet. So I'm going to shade lower than by clicking this button here. We click submit, and we're all set. This one is already in slope-intercept form, so I don't need to manipulate anything. I'm going to start at my y-intercept of -5, and then I'm going to use this number for my slope. Notice when there's a negative sign next to your slope, you can only use that negative sign once. You can use it with the 5, or you can use it with the 6, but you cannot use it with both. So I'm going to start at my y-intercept of -5, and I'm going to use this version, the -5 with the numerator. I'm going to use that version. So that means I'm going to go down 5, 1, 2, 3, 4, 5, but then I'm going to move +6 to the right. There we go. Now I'm going to choose my shading and my boundary line. My boundary is greater than, so I need a dashed line, and my shading should be above that hill. Click submit. This one needs to be manipulated, so I'm going to move on to another one that has, there we go, a sentence that has a greater than or equal to sign. So I'm going to manipulate this sentence first here. So x plus 3y greater than or equal to 9. Divide by 3. Now this is where some students get a little bit confused. When your variable is in your fraction, I highly suggest that you move it off to the side of the fraction, like this, and then you replace that empty numerator with a 1. So instead of x divided by 3, I'm going to use 1/3 x. Don't forget this negative sign can only go with one of those numbers. So I'm going to give it to the numerator, which is the 1. So the y-intercept is +3, and my slope is -1, 1 down, and +3 to the right. My boundary line is going to be solid, and my shading is going to be above the line. That's the basics for graphing linear inequalities. Now we're going to go back to equations and we're going to solve these equal sign sentences by graphing two on the same grid. So you may need to manipulate one or both of these sentences. So for me, I need to manipulate the second sentence here. So I have x minus y equals 2. I'm going to subtract x. But don't forget, you cannot have a negative sign in front of your variable. So you divide by -1. And there's my second sentence. Alright, so my first sentence is y equals -1/2 x plus 7. So I'm going to graph that one here. -1/2 x plus 7. So I'm going to start at 7. I'm going to give that negative sign to the 1. Down 1 over 2. Okay? Because this is an equation, I don't change a boundary, I don't have any shading. This is an equation. So everything on this green line is a solution. Nothing away from it is a solution. Only the points on this green line are the solutions. Now it's time to graph the second equation. So I'm going to start at -2. And my slope is an invisible 1. So up 1 over 1. And now I see right here, this is the point of intersection right here. So I'm going to name that point and write it in the solution area here with parentheses. 6, 4, just like that, a point. The actual intersection will be the solution to this system. Let's do one more. Alright, the first one does not need to be manipulated, so I'm going to graph it right away. 5, and then -1, +1. So that's my first equation. My second equation, 2x minus y equals 7. Subtract 2x minus y equals 7 minus 2x. Divide everybody by -1. And there's my sentence. So I'm going to start at -7. I'm going to go up 2 over 1. There's my point of intersection right here. And it is 4, 1. Okay, let's take a look at identifying quadratic and linear systems. These will be graphed for you already. As a reminder to you, when you have linear systems, that's two straight line graphs, they can either intersect at one location or they can be parallel and not intersect at all. In very rare cases, they could be overlapping, which would mean that they have infinite solutions. With quadratic and linear systems, you can have, like we see here in the picture, we can have 2 points of intersection. We could also have no points of intersection, right, where the straight line and the quadratic parabola don't intersect at all. Or you can have one very careful, I'm not sure if I can draw it properly, yikes, there you go, where you have just one intersection. So you can have one intersection, no intersections, or 2 intersections. So in this case we have 2 intersections, so we'll simply write the name of these 2 points right here in these spaces below. They are +1, -1 for that upper point, and then for this lower point here it is 3, -5. This one also has 2 solutions. This lower point here is -1, -3. And this upper point here is 3, 5. I think you're getting the hang of this one. So let's take a look at what we're studying this week, which is solving algebraically. Now this one in particular is an elimination method. Again, you always have a choice which method you want to use, but when you use the elimination method, we use that because typically they're both in standard form or they're both written in an order where vertically the like terms align. So let's take a look at this system here. In order to use the elimination method, you need to have coefficients that are additive inverses, right? Numbers that are opposite signs, same value. So here we have a -2 and a -1. And here we have a -2 and a +4. So I'm going to focus here because these already have opposite signs. They just need to be the same number. So we're going to use multiplication to change one or both of these sentences. And my top sentence here, I can make this term a 4 if I just were to multiply everybody by 2. I'm not going to modify my second sentence at all. So this becomes negative 4x, negative 4y, and 0. My bottom sentence will remain the same. No alterations at all. Now I'm going to vertically, up and down, combine these two sentences. So this will become a negative 5x. This eliminates. This becomes 40, which means x is equal to negative 8. This is half of my answer. A solution to a system has 2 answers because there are 2 unknowns. So you can use either the first or the second sentence. I'm going to use the first sentence. So negative 2x minus 2y equals 0. I need to erase and replace. Anytime I see a letter x in this sentence, I erase it and I replace it with whatever value is over here. So now I have negative 2 times negative 8, which is positive 16. Everybody else stays the same. Subtract 16 from both sides. Divide both sides by negative 2. And there's my solution. So make sure you type your answers correctly in the order that they should be, which is x first and then y. So our point here is negative 8, positive 8. That's our solution point. Negative 8, positive 8. So I'm going to go back here and type this. Negative 8, positive 8. Submit my answer. Next one. Again, with this one, I'm going to focus on the y's again because I know that 2 is a factor of 8, so 2 can become an 8, and they already have opposite signs. So I'm going to multiply everybody up here by 4. Keep everybody in the second sentence the same. Combine. And solve. Choose any sentence that you want. I'm going to choose the second sentence this time. Erase and replace. Write your answer as an ordered pair and type that in the solution box. Let's see if I can find one that has to do a little bit more work. Okay, this one doesn't require more work, but it does eliminate a different variable this time. So these have opposite signs and these have opposite signs. But I can't multiply 6 to become a 5, and I can't multiply 5 to become a 6, but I can do that over here because 7 and 14 are in the same family, right? 7 is a factor of 14. So I'm going to focus on eliminating these terms this time by multiplying everybody in my top equation by 2. Keep my second sentence the same. Eliminate, combine, solve. Now don't forget this goes in the y position. So now I'm going to erase and replace my letter y. So I'm going to add 5 to both sides, whoops, and get x is equal to 1. So 1, negative 1 is our solution. Okay, I'm going to go on to substitution. Now when we use substitution, we do this because all of our variables are not lined up. Sure, we could manipulate this. We could add 4x to both sides and use the elimination method. And if that's the method that you love to use, then you should use that method. But sometimes it's faster to use a method where the items are already aligned in the position for how they'll be used. When we use the substitution method, we need a variable by itself, because that means we can erase and replace these items into this sentence. So I'm going to rewrite my first sentence, which currently has 2 variables in it. Cannot solve anything with 2 variables. But if I know that y can be erased and replaced with negative 4x, then now I have one sentence with only one type of variable. And this is something that you can solve. Negative 6x plus negative 4x is negative 10x. Divide both sides by negative 10, and we get x is 5. That's half of our answer. So now I'm going to erase my letter x and replace it with a 5. And there's my response, 5, negative 20. We're going to do this one more time. We're going to solve using substitution, and we're using substitution because one of the variables is already by itself, or isolated. In this case, x is what we will erase, because x is by itself. We will erase this x, and we will replace it with this value. It goes right there. All right, so we take our first sentence, 3x minus 8y equals negative 50, which cannot be solved because it has 2 variables. We're going to erase this letter, and we're going to replace it with this value. Now we're going to distribute. We're going to combine, and we're going to solve for one letter, which is only half of our answer. Now you can choose any sentence, but I'm going to choose the second sentence because it's already isolated for x, and that's what I want to know. So I'm going to erase a y this time and replace it with a negative 5. Erase the y, replace it with a negative 5, and I get x is equal to negative 30. And there's our solution, negative 30, negative 5. All right, last one. This is an old topic, transforming formulas, and it's something that we need to keep practicing so we never lose our skill. This one is going to ask you to transform the volume of a cone formula, and they want you to rewrite the formula to solve for h in terms of r and v. That means get h by itself and get all of the letters on the other side. So here we go. There are no plus or minus signs on the right side of this equation here, so this is one giant term. I'm going to choose to remove this fraction first, and we don't divide by fractions, we multiply by the reciprocal, right? Multiply by the reciprocal. This is not necessary. You can just write 3. In doing that, now I can focus on the items that are multiplying, and if we're solving for h, we need to remove pi and r squared, and if they both need to be divided, it can be done at the same time. 3v over pi r squared is equal to h. So when we type that in here, we can type 3v, and if we type our fraction bar, it will put it in the numerator, and I'm going to type this pi sign, the r, and then I'm going to press Shift 6, or I can use this keypad over here, and that keypad, you can't see, it's a little bit off the screen. Here we go. That keypad has a variable, an exponent right here. Here we go. So you can type Shift 6, or you can use this Delta Math keypad. Okay, let's try one more time. This is the perimeter formula for a rectangle. They want us to solve for L in terms of P and W. And when I do that, I like to make this look like a little capital because sometimes I get confused and I make it look like a 1. Alright, so I'm actually going to write the P first because I want that minus sign to be after it. And I have a couple of options here. you can divide the entire fraction by 2, and that would leave you with this sentence in this format. We could have, going back here, we could have split our fraction bar like this and divided everything by 2, in which case I could get p over 2 minus 1w equals L. This is also an acceptable answer. And a third acceptable answer would be if you were to take that fraction and remove the p from the numerator. Put the p on the side of the fraction, and then you fill that empty space with a 1. All 3 of these are 100% correct answers. All 3 of these. If it was a multiple choice question, you'd have to choose which one matches the multiple choice. If it's a short response, all of these receive full credit. So I'm going to type this giant one. Let's see what they say. P minus 2w over 2. Let's see what they say. See if they wanted us to simplify. Nope, we got it right. All right, let's try one more. The formula for a trapezoid, they want us to solve for B1. They want us to solve for B1. Okay, so as I'm writing this, let's see, area equals 1/2 height times base 1 plus base 2. So I'm going to remove this fraction first, and I'm going to multiply both sides by 2, giving me 2a equals h times b1 plus b2. Then I'm going to remove this h, giving me 2a over h equals b1 plus b2 with no more parentheses because there's nothing timesing anymore. And to solve for b1 means I just need to subtract b2 from both sides, giving me a fraction minus a b2. So 2a over h minus b2. So 2a over h, arrow off to the side, minus, and then the b1, b2 items are right here. All right, last one. I know sometimes these formulas can get pretty crazy looking, but remember, there are items that are not mathematical, like these little subscripts, right? M1, M2, they're subscripts. You don't need to separate the M's from the 1's and 2's, but if you were solving for R, we would have to square root. But we are not solving for R, we're solving for M1. So let's get started. F sub g equals g times m sub 1, m sub 2 divided by r squared. All right, well, m sub 1 is in the numerator, and you can't touch any items in the numerator until you clear the denominator. So our first move here is timesing both sides by r squared. And it doesn't matter which way you write this r squared and fg, but I'm going to write it like that. And now I see that both g and m2 are multiplying m sub 1, so I'm going to divide by them at the same time. So that's my answer. F sub g r squared over g m sub 2 equals m sub 1. So again, it's always the same inverses. Dividing, multiplying, adding, subtracting. Now we're going to type this in. F sub g r squared all divided, whoops, r squared, let's get out of here, all divided by, what was it? G m sub 2. Capital G m sub 2. All right. Okay, good luck.